Hello everybody, here I am with homework 3 and now as we've mentioned before, the homework 3 and 4 will be a team homework, so you will work in teams, and the teams should be formed of three, at least three or four, ideally four students. So and everyone has a role in this team. So there will be a team leader, a reporter, and the rest will be researchers. Now the aim here is to give you the teamwork experience. So because you should also learn how to work in groups, in teams. Now you should assign your roles using the DOS system. You will also create your team in DOS. The responsibility of the team leader is the whole organization and the arrangement and sharing the work, everything. So, and then there's a reporter who should get jobs done in that area. Now, you can use any word processor you like, but for creating the report that you will submit for this homework. Now, the report should be a little bit more in depth because there is an introduction, a conclusion section, and you should explain your work to the best you can. Now, here about the explanation, because there will be an oral examination, you should keep in mind that if we ask some questions, for example, if you're asking about the pole zero map, did you look at the pole zero placement of this whole design, then there should be a pole zero map in your report, so you can open up that figure and show us, and then then we will talk about that. The same goes for the, for example, root locus, or the closed loop step response, or maybe the transfer function and the numeric values of them. So be prepared in that sense. If someone looks at this design, what could be his concern? What would he or she might want to see for this question? So keep that in mind during the preparation of the report and your work. Now, the little details are important here. If you use any internet or textbook reference, you should provide your reference of that. If you have some comments, if you have some explanations, please provide them during your report preparation. So everything should be in place. So if someone takes this and looks at it, they should get the full view and all the details about the work done. So, as usual, do not provide any code. You may upload using any one of these, Google Classroom, DOS, or Ninova. Please do not upload any M files, RAR, or zip files, because you're asked to just provide a report. So that should be a PDF or maybe a Word format, word processing format, but PDF would be the best solution here. And do not send any homeworks via email. There will be something that you should send to this mail here, by mail. It is the following. Since you're forming a team, and since there are roles and there are assigned roles in this team, at the end of your work for this homework, you will be grading yourself and your colleagues in the team between or on a scale between 0 and 100. So you should also assign yourself a mark in this on the scale. So how did your team leader work? How was this performance or her performance? Was the reporter good? Did you do a good job, or did you experience any problems? So you should talk about that in a half page and a half A4 probably. So You will evaluate all the work and everything during the team work. So if you do not mail this personal report here, you might face some problems in your grades. So please be sure that you send this before the oral examination. So now you work in teams in 4, ideally 4, because it's a heavy job here if you think about it. Team of 4. Do not attempt to be just one team individually. So please find some colleagues to form a team. You will work in groups. Your report for this homework and homework 4 will be a little more in depth, and you will also provide a personal report for the whole experience here. Now, after the submission, we will hold some oral examination, and during these oral examinations, we will try to understand your level of understanding. We might ask you some questions to the homework specific, or maybe general, and then you will also cover the report, and we hope that this will help you a little bit more, because the homework 1 and 2, they were pretty much static in that case. But here we will have some interaction, and hope that interaction will help you in the during the learning process. So let's look at the homework itself. Let's see what the questions here are. Now we have a 4th order transfer function here, and in this transfer function we don't have any zeros. The task here, the first task here, is to design a PID controller, but this PID controller design here focuses more on the dominance factor. So as you can see, there is no settling time, no overshoot properties. There is directly the point that we should assign the dominant poles to. But the issue here is, since this is a high order system and we have PID zeros, we are adding a pole to it, we have a bunch of poles and zeros. We are focusing here on the dominance factor, or we are focusing on placing the poles and zeros in such a way that we have the maximum possible dominance present in this design, in the closed loop. Because if we increase the dominance factor, then we will have the desired poles and the effect of the desired poles in our transient response in the closed loop step response, basically. Now, of course, you should explain your design method, provide the necessary results, and talk about your design. But as a suggestion, I would say that using tabulation can give you some hints about it, but the actual design should be more based on theoretical facts. So you should be careful here, because the tabulation methods might cause you some problems or might give an idea about the solution, but that's not the actual point of this question. So what you should pay attention here is that the dominance factor and how you can satisfy that. We have mathematical tools for this, and it is asked you to use those mathematical tools. Now, what are those? That's actually the question itself. So it's a bit different than the previous PID controllers. So keep in mind that tabulation is just a verification method, not the method itself, actually. Now, then there's the second task B, and you're asked to repeat this design using a PID controller, but most of the time using the PID controller is as follows. You design a PID controller, and then you take the PID coefficients, especially the integral and derivative part stays the same, but you kind of use the p-type controller and break it into parts and come up with a updated controller, PID controller namely, and it works well. Now for this question, you might do that, or it might also be possible to rethink that the PI/PD controller from scratch, because there might be a possibility that if you use the advantage of the PI/PD controller, that you can assign with a higher dominance factor. So keep that in mind. It might be, or it might also not be the case for that, but keep that in mind and keep an eye on that, because rethinking the PI/PD controller might help in this question. So A and B tries to achieve the best dominance factor for this system. This is part 1. Now part 2 is a bit more different, focuses on a different system. It is a first order system with some delay here. And it's a fluid level control system where you apply some current, and then the height of the, or the level of the fluid changes, and you're trying to control that using this current. Now, here the actual question is about delay time, or dead time. So you're asked to determine the stability interval for using 3 different PADI approximations for the P-type controller. So you will be looking at the PADI approximations of this transfer function, and then you will see what the intervals are, and then you will comment on differences or similarities or the reason behind these different intervals. So this is a discussion about the stability of the system. And in E, you're asked to synthesize a controller or design a controller of your choice. It could be PI, it could be PD, it could be PID, or it could even be PI/PD. It's up to you. You can choose one of these controllers, and you can choose any PADI approximation that suits your needs. So you can feel free about the PADI approximation. So your choice of controller and your choice of PADI approximation together will give you, hopefully, the requested closed loop characteristics. And here the only request is the non-overshooting part. So obviously the settling time is up to you. You can choose the settling time. The only thing that we are looking here is that you have some delay, you have a non-overshooting requirement. You should meet these. So meet the specification, choose your controller. So it might be the case, if you choose some of these controllers and approximations, it might not be a good design. So then you have the option of just reporting that we had this design and this was the result. We didn't achieve the best here, and then the next step would be an iteration here. So maybe if we choose the control structure as follows, then or if we change the PADI approximation, then the result gets improved, or so on and so forth. So you get the idea. I don't say that you have to design all the PI/PD controllers and use all the PADI approximations. That's not the task here. But if you make a choice and it does not come out working well, then you should update that. You should maybe change the controller type or the order of approximation here. So please do not choose one of the controllers and the PADI approximation and then end up with a bad result, and then in your report it doesn't work and that's it. That's not the case. There should be a controller and a approximation that works well. So, but I have to warn you, because most of you will probably miss this point. So please, during the verification step. So the verification step is the point where you did synthesize your controller or design your controller. And it's the step where you look at the results. So you plug in your controller and look at the closed loop characteristics and so on and so forth. Now during that verification stage, you should go ahead and use, for example, Simulink, and use this transfer function, and then add a delay element, which would be this part here, and then use your controller and the whole feedback structure, not the PADI approximation transfer function. So you have a delayed system, you look to design a controller, but during the design you see that if you use any controller and a system with delay, the closed loop characteristic polynomial is not a polynomial anymore. It's a quasi-polynomial because it will have some exponential terms in it. So to overcome that, you use the Putty approximation, but this is an approximation. This is not the actual system. So looking at the controller and Putty approximation closed loop gives you some hint, but it's not actually the verification. You should go ahead and use your controller and the actual system and come up with a closed loop and look at the step response. So therefore, you have the option of using Simulink and adding a delay element and then your controller and the whole feedback structure, or as you will see in the laboratory session, you can use the transfer function representation in MATLAB in Control System Toolbox. If you provide the option I/O delay, which is input-output delay, so using that option and providing a numerical value gives you the ability of defining such systems and look at the step responses of them, or using the feedback structure and looking at the step response of that. So you can either use the Simulink and delay element approach, which might be suitable for you, or if you still want to stick with the code, you can also use TF. So TF num, the numerator, comma the denominator, comma IO delay in quotes, and then give the delay amount, and you can see. If you look at the TF documentation, help TF or doc TF in MATLAB, you will see that there is also an example for the delay definition of a system. So to wrap it up, you will form a team in DOST. You will define that in DOST, and you will assign roles to everyone. By the way, all the numeric values will be team specific, so that's that. That's also the reason why I have boxes here, not numerical values. So there will be probably in our class maybe 4 or maybe 5 teams whatsoever. So you will work in teams, you will create a detailed in-depth report, and then you will also create a report about your performance in the team working experience. You will mark yourself and your colleagues and send it to me via mail, and then we will have an oral examination and we will have a talk about this. The whole aim here is to have more interaction and communication during the homework process, because if you think about the homework in 1 and 2, they were pretty much static, and they were not bad, but hope that homework 3 and homework 4 will be in terms of learning and in terms of understanding the whole concept here, will be more fruitful, hopefully. So we will have an oral examination, we will ask you some questions, and everything will be taken into account during the grading. These are the questions. If you have any questions, you can feel free to ask on Google Classroom, and hope that you will enjoy this homework. Now, that said, see you in the laboratory sessions, and that's it pretty much.